Hey, seahorses! Welcome back to another episode of STEAM. It's Mr. Urban
and Miss Martinez. Today we have two special experiments for you guys. After spooky season, you may have seen it. Have you guys ever heard of dry ice?
So our question for the day is, what is dry ice? How can ice be dry? And what does it do?
After conducting some research about dry ice, we discovered that dry ice is made out of carbon dioxide.
They take the carbon dioxide and cool it to negative 109 degrees Fahrenheit. Water freezes at 32 degrees Fahrenheit, so that is really, really cold.
Fun fact, did you know we breathe in oxygen? It's distributed through our red blood cells, our organs, and muscles. Then they break down and we breathe out carbon dioxide. The exact same thing as dry ice. Except dry ice is frozen at negative 109 degrees.
There are three states of matter: solid, liquid, and gas. When you cool things or freeze them, their particles lose energy and become very dense, like putting water in the freezer to make ice cubes.
Liquids, their particles have more energy and they float more freely. Like water, you could shake it around and it'll splash everywhere.
With gases, particles become very energized and move freely everywhere, kind of like steam from boiling water.
Exactly. So after our research, my hypothesis would be dry ice will melt into a liquid just like regular ice.
Well, my hypothesis is that since we know that it's so cold, I think it'll never ever melt and it'll stay there forever.
Interesting.
What do you think is gonna happen? Okay, now we're ready, seahorses. Let's get into it.
All right, let's get a little chunk of this out. Whoa, that is cold. I think we're gonna need something to break this apart. Ooh, that is freezing.
Like a knife?
I think I have just the thing right here. Let's try it. Aha, perfect. Ooh, that is cold. All right, so here's dry ice. Let's get a regular piece. Sounds good. Now let me adjust the camera so we can watch this. Might take forever.
Make an observation. Can you notice the difference between dry ice melting and regular ice melting? The dry ice doesn't melt, it vaporizes back into carbon dioxide.
Alrighty, seahorses. So for our first experiment with dry ice, we're gonna do cold water versus hot water.
What do you think is gonna happen?
So we got our cold water in here. Then I'm gonna pour the hot water.
Ooh, that is cold.
And then Mr. Urban got some
You wanna put one of those
slices
in?
of dry ice.
So this is the cold water? Whoa.
Whoa.
So I wonder what's gonna happen. Whoa.
Whoa. So they're both bubbling.
Oh, but this one looks a little more even
Energetic.
bubblier. Yes.
Energetic. So you can see the bubbles coming up.
Oh, so I think what is happening is the hot water is melting the carbon dioxide quickly, which makes it a little more explosive in the bubbles.
Totally.
That is super cool.
Wow.
What do you think it would look like if we added some food color into this?
Even better.
Let's find out.
Okay. Okay, Mr. Urban, I think I know which color you're gonna pick, but what color do you want?
Blue.
Okay.
You know it. Oh, yeah.
And Miss Martinez is gonna go with pink.
All right. Let's put a couple drops in.
Gotta squeeze it.
We might need more ice as well. Yours is still bubbling. Mine's already almost bubbled out.
It is.
Here you go.
The ice is getting smaller as it goes on.
Oops.
Oh.
Can't really see the bubbles. We might need to use a different container. but that is still super cool. And the warmer water is still making the bubbles bigger.
Yep.
That is awesome. So all of this is carbon dioxide that used to be frozen at negative 109 degrees Fahrenheit, but as it becomes room temperature, it turns into a gas.
Wow.
What are the cool things you think we can do? Let's let these bubble up. Let's try these cylinders.
All right.
I have a crazy idea. Let's put a balloon on these.
Ooh, I like it.
Let's use hot water in both of them.
Okay.
So let me put some hot water in here.
We'll stick with. Got a blue balloon for Mr. Urban. And a pink one for Miss Martinez. So put it in that hot water.
Alright. Get some pieces of ice. Hope this is enough. Alright, here we go. Let's see what happens. Let's put a balloon on there. Whoa. Oh, look at it go.
Oh my god!
That's awesome. Oh no. It's too much. It's too much.
Please don't explode.
So as the carbon dioxide is released in the warm water, it is moving upward into the balloon and filling up the balloon. How cool is that? That is awesome.
Wow. Kind of looks like a lava lamp.
Hey, it does, yeah. I wonder if we put food coloring in these, would it look like a lava lamp?
I assume so. It looked like a lava lamp with those ones. Oh my gosh, yours is filling up a lot.
Uh-oh, mine has a leak. It's gonna explode!
Yeah, I think mine's done bubbling.
Yeah, mine's just...
But the gas is still staying in there.
Yeah. The gas needs somewhere to go. And this is full of water, and the rest will fill up with gas. Very cool. How about this thing? Should we try to put a bunch in here?
Yep.
Let's put a lot in here and see what happens. Can you please fill that up with hot water?
Yes, sir. Do we want to pick a color?
I'll let you pick this color.
Okay.
Because you already know what I'm gonna pick.
That's true, that's true.
Whoa! It's like a volcano! That
Oh my
is cool.
gosh.
That is really cool. That is a lot of carbon dioxide. So when it freezes, it becomes really dense into the block of ice. I can't hold this for too long because it's so cold, but this is what a big chunk of dry ice looks like. It looks like a giant, compact piece of snow, really, but it is freezing. Again, negative 109 degrees Fahrenheit. And water freezes at 32 degrees Fahrenheit. That is so
Wow.
cool. What do you think will happen if we throw some soap in some of this?
Ooh, I'm curious.
Let's grab a bowl.
Alrighty, seahorses. So for this next experiment, we're gonna see if we can capture a carbon dioxide bubble. So I have a water bottle and I'm gonna put some dish soap in here. I wanna make sure this is really saturated, so that's why I'm using a water bottle to shake it up. Oops. So we're gonna put hot water and dry ice in here. I'm gonna put this mixture in here with a paper towel to soak it, and we're gonna see if we can capture that bubble.
Here's the hot water you ordered, Miss Martinez.
Thank you, Mr. Urban. Okay, so I'm gonna fold this and put it in here. We want to make sure that the paper towel is soaking wet. Okay. Mr. Urban, if you want to put some dry ice in here.
Absolutely. A good amount?
Yeah, a good amount. Oh, yay. There we go.
Bam.
Okay, so now I'm going to add the hot water.
Oh, it's going to get crazy.
Okay. Maybe you pour it so I can get ready.
Okay.
Okay, hold on. Let me get ready first.
It's going to be wild.
Okay.
Are you ready?
Yep, I'm ready. Oh.
Whoa. What if we just do half of it like that? Just leave it like that. Lay it down. Whoa. There we go. How big do you think it's going to get?
I think I could get pretty big.
How strong is the soap is the question.
Yep. It's Ajax triple action.
Whoa.
That looks
cool.
awesome.
Oh, there it goes. I'm happy.
Hey!
Oh, nice. Oh, that's so cool. It's like a bunch of different bubbles and they individually pop. Poke it.
Oh my gosh, it just goes in the area that you poke.
Super cool. Wow, well those are really cool experiments. And I think after going over our experiment, our results are that dry ice doesn't really melt. It just vaporizes straight into a gas.
We noticed that when dry ice comes into contact with liquids, when one is hot, we have a more explosive reaction, and when the water is colder, it's still a reaction, but not as explosive.
And that's because the gases from the condensed dry ice are released quickly into the air, while in the not so warm water, it slowly fizzles. So, big difference. Oh, what a chilling experiment.
After looking at our data, we discovered that dry ice doesn't melt, but rather vaporizes back into a gas.
How cool. But now it's time for part 2 of our STEAM episode, so let's head to the lab with our volunteers. For the past couple of weeks, we have been begging the Tooth Fairy for some teeth, but she is very busy and hasn't given us any.
So, we have 3 students who decided to donate their teeth in the name of science.
Let's get them.
Fun fact, did you know that your baby teeth are actually sitting on top of your adult teeth? Your adult teeth grow in, dissolving the baby's teeth roots and push the baby teeth out. How cool is that? Your teeth are very similar to bones, except they are alive. They are supplied with blood and have nerve endings.
Alrighty, seahorses, so these are our 3 amazing volunteers. We have Miss Ashlyn Montano, Miss Delilah Sadler, and Miss Jasmine Diaz. So they have decided to donate their teeth in the name of science, which is totally awesome. So, Ashlyn, what is your favorite soda? It doesn't have to be any of these, but your favorite soda. Dr. Pepper, Delilah, Red Bull. She's got that sweet tooth. And Jasmine's is the Crush. Nice. Alrighty, so Jasmine, what do you think will happen if we put your teeth in the orange?
I think that it would just sink and then bubble because it's in like a container that has a little bit of holes.
True, true. Delilah?
I think because if the bottle had more air in it, it would bubble more because Our teeth are actually a bone. They're actually not like a gum, a part of our body. The only part that is a part of our body is the gums.
Ooh, great hypothesis. Ashlyn, what do you think?
I don't know.
Okay, that's okay. Sometimes we don't know what's gonna happen, but we're gonna find out.
Oh.
Alrighty, girls, go ahead and show us those pearly whites.
Awesome. And for Delilah's tooth, we are going to simulate a cavity. We broke it in half, and we're going to pretend like there was a cavity and see if that changes the results.
Ooh, satisfying. Okay, you can go ahead and pour.
Smells good.
What do you think all of these drinks have in common?
Sugar.
Ooh.
Alright, Jasmine, drop it in. Alright, so we are going to wait and see what happens, and we're going to check it every week.
Oh!
So go ahead and put the lid on, okay?
It just fell down for some reason.
It's because it is more dense than the liquid, so it won't float, it will sink. Good job.
Oh, I have it part two.
Alrighty. Delilah, you want to open that up and drop your teeth?
Can't open it.
Oh yeah,
Okay.
sorry about that.
Satisfying. Alrighty. 1, 2.
And don't forget, we broke this tooth in half to simulate a cavity. We're going to pretend like there's a cavity to see if it affects the tooth. Very good job.
I think one of them is floating on the
Alright.
top of it.
One is kind of
Because the other half is part of the nerve.
A little bit more heavy.
Yeah, it's part of the nerve.
And
Okay.
last but not least.
Do you want to open it, Ashlyn?
Oh, it's gonna blow up! It's gonna blow up!
Whew.
Got good reflexes. Alrighty, Miss Ashlyn.
So does fizzy sometimes. Oh, I already tell it already wants to go out.
Perfect. Alrighty, ladies. Thank you so much for donating your teeth, and thank you to the Tooth Fairy for letting us have it. And we're going to check on this in a week or maybe 2 weeks, and we're going to wait until we see some results, okay?
Okay.
See you later.
Bye.
We'll be back to check on the teeth in a couple weeks to see the results.
Thank you so much to Jasmine, Delilah, and Ashlyn for your donation of your teeth.
Well, see you later, seahorses, and remember, brush your teeth.